A big hello to everyone joining us today for this awesome presentation on local development for Lightning Web Components. My name is Nisha Bakshi, and I'm on the developer marketing team here at Salesforce. Before we begin, just a quick note that when considering future developments, whether by us or with any other solution provider, you should always base your purchasing decisions based on products and features that are already generally available. And with that, we are ready to get started with today's session with our incredible product team, Nicholas Kruk, Chris Gray, and Nate Totten. All right, guys, take it away.
All right, thanks a lot. Welcome, everyone. So today we're going to cover a number of different things. We're going to first do a bit of a review of some of the developer tools that you use for LWC development. We're going to talk about what actually it means to have LWC local development available, and we're going to discuss some of the roadmap, some of the things that will be coming post our first beta release, and then Nick has a really great demo for us, and then we'll have time for Q&A or for you to provide feedback. What thing we definitely are interested in hearing. What you like, what features you think are missing, how you're going to use this. So really be good to hear that at the end in addition to the QA. Cool. So hopefully everyone's had a chance to use the Salesforce extensions for VS Code. If not, though, I just wanted to quickly cover that just so everyone's on the same page. So our official first-party tool for Salesforce development is Visual Studio Code. We develop a number of extensions for that for all sorts of Salesforce type development. So for Apex, for Aura, for Visualforce, and of course for LWC. Contains a number of productivity features for all of our languages and frameworks. Contains debuggers, things like refactoring, code completion, and testing tools. And then also built on top of a number of standard protocols so that these sorts of tools can be used in other IDEs with our partners. And also then, of course, Visual Studio Code is a great editor for other languages. So it's a lot of our developers have said that it's really nice to be able to do their Salesforce and non-Salesforce development inside of VS Code. And then also the CLI, which is sort of the core piece of modern Salesforce development and what we build on top of for the VS Code extension. So, the idea with the CLI is we want everything to be scriptable, automate, and be able to automate everything so that anything you can do, the goal is that anything you can do in the UI or through the APIs of Salesforce, you could do through the CLI. And yeah, so manage data, source control, all that stuff. And one of the really cool things just to point out here that happened just recently with our latest release for summer 19 is you actually can now use the CLI to deploy to production in various ways. So there's some really, check out the docs on that. You can now start moving from some of the older tools like data migration or whatever to deploying to production. So really nice new addition there as of recent. As far as LWC specifically in VS Code, this is we consider our the most powerful productive developer experience for LWC. So VS Code is by far the most popular IDE now for web-based development, and we've really built on top of that for LWC. So full code completion for HTML, JavaScript, CSS. Inline documentation, so you can hover over everything from components to JavaScript objects, properties, etc., and get full documentation and get links actually to the web-based documentation. Linting with an open source tool, with a community built tool, and then with our custom rules for ESLint, and really nice code formatting with Prettier, all sort of built in and available in VS Code. And then, like I said, it's built on the functionality that VS Code already provides. So a lot of really great stuff is available there. Refactoring, go to definition, all those different productivity capabilities and navigation productivity features. So really great stuff there. Awesome. So before we talk about what LWC development is, I just want to kind of set the ground with what our goals here. So, we get a lot of feedback, obviously, from developers that they want things to be faster. Obviously sometimes doing a lot of deployments in a day or can be cumbersome. Sometimes deployments take longer than we'd like, which we are working on. We've got a number of efforts to sort of make deployments faster. But obviously, even if the deployments are super fast, nothing beats just having something on your local machine. So our goals here with local development is to give a much faster developer experience, and by that I mean faster in that life cycle of from when you write code, hit save, to be able to see was there an error, or is this working? Is this, is it doing what you want to do? So rather than going through that save, deploy, refresh process to make that, really the goal is to have that whole thing take, say less than half a second, rather than taking, 3 to whatever, 3 seconds or 5 seconds in a really good case, now up to like, potentially, a minute if you have to do a big deploy. So really to get that whole, again, write code, save, find out the results life cycle much faster. And then, just all of this will increase productivity. So, just building we view local development as just one part of the tool set that we're building in VS Code and the CLI to just really enhance your productivity. And then from a developer's perspective, the best local environment is going to be the closest mirror of production. So we'll talk about more in detail. I'll talk about more in detail what this means, but our goal is to have your local development environment with LWC be as close to production as possible, so that obviously you can see if something's not working locally, or if something's working. The expectation should be that if you can get something working locally, it will also work once you actually do a deployment to the org. We're not going to be quite there yet in our first release. I'll go into what that means later on, but that is definitely the goal. So basically, what are the core features of LWC local development? So live rendering of components, as I kind of mentioned, without pushing to your org. We built, this is an Express server, Node.js server with LWC compilation, all running locally on your machine. You may have seen the announcement at TrailheadDX that we're open sourcing, or we have open source now, the LWC framework and compilers and tools. So this is all the stuff that basically allows us to build local development. We're taking all those tools that are open source and we're packaging them up in a way that run on your local machine. One thing to note here is that this does only work with LWC. This is not going to be this isn't something that's going to work with Aura. We likely will probably never make Aura work locally for a lot of reasons. We do want to bring, over time, we want to bring more capabilities of the org, potentially running, like things like running Apex classes and stuff locally, but for now it is only LWC. And we will be releasing this very soon, so summer, at least for those of us in the Northern Hemisphere. Our goal is to have this out in beta in the next month or two for you to try out, and then continue to add on top and releasing GA sometime after that. So as I kind of mentioned, VS Code and the CLI, there'll be integration. You'll be able to run LWC local development in both places. So there'll be a plugin for the CLI, so you'll be able to run LWC development, straight through the CLI, or there'll also be integrations in VS Code where you'll be able to right-click on a component and to open that, or be able to start the LWC local dev server from VS Code. And also for those of you who don't use VS Code, who use other tools, Illuminated Cloud in particular, we've already been in. It'll also work in those environments. I've already been speaking with Scott about Illuminated Cloud to make sure that also has the same LWC local development experience. So that, and obviously if any other tooling vendors want to integrate too, we're certainly happy to have that as well. Cool. So the first thing, the most basic, what does this mean? A local rendering of components. So you write an LWC component and you want to preview it in the browser, you run the local server, and you'll be able to see that in action. You'll be able to see that locally. If you have multiple components that are like nested or referencing each other, it'll render all of those components, and interactions between components will work as expected. So whether it's events or whether you're using pub/sub, as we've kind of demonstrated in our documentation, a number of the examples, all of that will be able to work locally. And when you make a change in your code, as you'll see in the demo, if you make a change to a style or a HTML or JavaScript or whatever, you'll see that live reloaded almost instantaneously, all right in the browser. So that's kind of the most basic use case is just this. I think this is kind of the a lot of the core to it that I think a lot of people will use just for even just like simple things like changing the styles or making sure the design of your component is exactly right, making sure the colors are right. Obviously, I do it when I'm playing around with Salesforce. CSS is hard, so it sometimes takes dozens or maybe more deploys to that scratch org before you get everything just exactly as you write. And as I've been using local development, that whole process is a lot easier. It's save it and it refreshes. Oh, okay, I didn't get the color right, or the padding's not right, or whatever. So you can kind of see all that really quickly, in the browser, which is great. And then the next thing here, obviously, a big part of developing an application is data. So with LWC, with the local development server, you'll be able to connect to real data in your org. So you'll be able to, that local component, in this case, I'm demonstrating, I have a screenshot here of a component that's part of eBikes, this product filter, and those categories are pick list values, and the category material and level there are pick list values. So anything that you're doing inside of LWC with like @wire, or with Lightning Data Services, or the UI API or Apex controllers, you'll be able to use in your local LWC components. And then once if you've created a scratch org or authenticated with a Sandbox or whatever, the local development server will proxy any of those data requests actually to the org in real time, so that you can actually see that component in action, which is really cool. And this, like I said, this really is any data source. So anything you can use in LWC connected to an org will proxy and work locally. And error handling. So this is actually this is one of my favorite features about LWC local development. I think when you're doing development and everything's working, the deployment to the org isn't maybe that big of a deal. Like it's if you write a bunch of code and then you deploy it and everything works, okay, great. It takes a little bit of time, but it's not that big a deal. You hit refresh in the browser, great. But that's as we all know, that's not the reality, right? Like we all make I make a lot of mistakes. We all make mistakes while writing code. And today, like I write some code, I make a mistake, I kick off a deployment or a push to my scratch org. And I'm going to see that error, in the output. I'm going to see, maybe a CLI output, or maybe something inside of VS Code that's going to kind of say, hey, there was an error, with the deployment. But like that deployment failure can take a little bit of time. It's kind of hard to like parse that error sometimes, depending on what it is. It's a somewhat cumbersome experience to find out that I made a mistake, which makes the whole making a mistake is frustrating enough, but having to take 30 seconds to actually figure out what that mistake was, having to wait for the deployment to fail, just adds to that frustration. So we've really spent a lot of time making the error experience in local development awesome. So basically you're going to see, when you hit save, you're going to and have that local development server running, you're going to see, instantly the error, what the error number is, what the error message is, which is shown here in the top. You'll see the file where that error occurred, and it's noted here, the line and the column where that error occurred. And then we actually will give you, a code snippet here with that line actually highlighted, where that error occurred. And then of course you can expand, to the full stack trace if you want to see that. And also there's a link in here even that will open VS Code if you're using VS Code, it'll open VS Code actually to that line where that error occurred. So this, this makes it much easier and much faster to actually find and discover errors. And this will work with eventually this will work with everything. So this will work with JavaScript. It'll work with work with HTML, and I suppose with CS. I actually don't know if I assume we'll have it work with CSS also if there's a parser error in CSS. So you so really, like I said, this is my favorite feature. It's errors are never good, I guess, but when we can make them easier to handle it, I think that'll be really great. So those are the things. What I've shown so far is what we're planning on launching in our beta release that's coming in the next month or two. I want to talk a little bit about what's coming after that. So in addition to proxying to data to the org, we also want to make it so that you can use local or mocked data. So for simple things like objects, you'll be able to use what the plan is, you'll be able to use the same data format or maybe augmented on top of that you use that you can use for seed data in your Scratch org, if you're familiar with the command data tree import. So you can import data into your Scratch org. We want to make it so that you can use that same type of data to mock local objects in your org. And then for more complex data and services, there'll be a way to essentially record API calls. So what this is showing here is an API call, in this case to the data service for accounts, and you'll be able to record the results. So you could imagine for Apex controllers, for example, like you don't really want to mock that out locally. You just want to deploy the Apex controller and then call it one time and then record the result and then save that locally. So you'll be able to replay that over and over again as you're doing your development. So this is going to make it'll make it so that you can do more work essentially in an offline, without making network requests. Really, the biggest thing though that which will make your development faster. But I think one of the really big things that this enables is repeatable testing. So this will enable you to build full unit or integration tests with your UI without having to have an org spun up. So ideally, you would be able to write end-to-end tests of your entire UI with all of those APIs and services mocked out, so that you could find UI level problems much easier. And then Flexi Pages. So I did demo this in the Trailer DX developer session, but really, like when you're doing development, like it's one thing to see one component, get one component working, but obviously like having components work together, testing those interactions between components is super important. And obviously one of the main ways that you wire up components together in a Salesforce app is through Flexi Pages. So we're going to make it so that you can you'll basically be able to locally emulate Flexi Pages, so that you don't have to build like a fake LWC component that has like your three, like in this example, like these three, the filters component, the product list component, and then the product results component. You don't have to build like a fake one just to do dev testing. You can actually use that emulated Flexi page locally, so that you can test all those interactions, how multiple components work together. And then finally, I mentioned we want for this environment to be for the local environment to be most useful, it needs to be as close to production as possible. So in the initial beta release, it's not going to be fully it's not going to, there's going to be some limitations in terms of like even like APIs that are available and stuff. So there's going to be things you'll have to work around for local development. But over time, we're going to be adding essentially full production capabilities. So this means like Locker locally, the navigation services locally, if you want to do things like toast notifications or modals, really any API that's available in LWC for Salesforce development, we want to either either ship that with the local development server so you can use it exactly as it is in production, or have some sort of like local stub or mock of it so that you don't have to modify your components in the initial release. Like I said, there's going to be some things if you're using like some of the stuff in navigation APIs, you may have to have like you may have to like handle that or like mock it yourself in the beta release, but over time we want that local environment to be nearly identical to production, so that you can be confident that once you get something working locally, really it's like a single deployment to production, not to production, but to a scratch or your sandbox, and then you test it, but it should work out, it should work unmodified if you got it working locally. Cool. And so with that, enough talking. I'm going to switch it over to Nick, and he's going to actually show this in action. So
cool.
Pass this to him.
Thanks, Nate. You want to pass me presenter?
Yep.
Perfect. All right. Looks like this is all working. Great. Cool. Thanks, everybody. Hi, I'm Nicholas Kruk. I'm a lead software engineer on the Lightning tooling team. Really happy to be here with you guys, showing off some of the stuff our awesome team has done. Really happy with what we have so far, and excited to show it to you. So, historically, like Nate was talking about, Salesforce has really relied upon, your UI components having a connection to an org in order to really render and be able to display them. Now with LWC being open source, we really have this, modern standards-based approach that allows you to do development the same way you would with React or any other modern framework that's out there. And that, also comes with the benefits of having local development. So first, let's talk about the environment that I have set up locally here. So I've got a standard SFDX project, which is the LWC recipes project. And then normally, if I wanted to see these components displayed, I would push this to my Scratch org, which I've already done prior to this demo. So you can see here, I've got, the hello components here on the page. And really, the LWC recipes project is just a standard patterns-based project that kind of gives you examples to work off of when you're starting on LWC in terms of, composing components together, how to do, child-to-parent relationships, these types of things. Also showing you if you want to use third-party libraries, basically any pattern you'd want to use with LWC, you can find it in this project. So if you haven't checked it out, it's already publicly available and open source on GitHub. You can just Google it. You'll be able to find the source, take a look, and start playing around with it. So I have this set up and pushed to a Scratch org. So if I want to jump over to VS Code here, I can show you it's basically just the same list of components in a standard, SFDX project setup. So anytime I want to make changes, I would just come in here and make changes to these components, and I'll be able to see them, in my org after I've pushed. But now with local development, that's all changed. We can kind of jump on over to the command line here, and I can run my SFDX command, which is how we're going to distribute local development initially. So if I type this command, this will let me launch the local development server. So you'll notice when you first launch, it takes a second, but you'll see this link here that says, your server's up and running. You can click this link, and that will launch you over to the local development server here. So give it a second. This is kind of the initial landing page we have now. Obviously, this is going to change, but essentially the thing to take away from this is, we have a list of components that you saw here in my VS Code workspace on the left. That same list is showing up here in the right in this component section here. And we're going to allow configurability of the server and things through a configuration file, but none of that's really important for what you guys came here to see. So essentially, whenever I want to start working on a component, I can just type in the component name here and filter down and start looking at any individual component. So those hello world components that I showed earlier in the browser, you'll notice this is in my Scratch org. I can see that same component rendered here locally at localhost, /preview, and then the actual component name. Now, what this is doing under the covers is actually we have an Express server, and that Express server is essentially hosting these components, compiling them on the fly, and then exposing them through an API endpoint. So for any given component, I can look in this local dev server directory, and I can actually look and see the compiled source. This is all happening on the fly from the server side. not a lot to understand there, but just understanding all the complexity of what's happening under the covers. So this is rendered on the fly. You can essentially go into any of these components, and if I want to look at LL binding, this shows a little bit of a different style component. And this is live data. This isn't fake. So as I'm typing, this is actually updating a property, and it's being tracked in the UI. So jumping back over to VS Code, if we wanted to look at what the source looks like, as I mentioned, this is a component that has a tracked property with a change event handler. And so as I'm typing there, it's getting updated. But you'll note that, let's say I wanted to make changes to this component locally, and then see the updates. I could change this to goodbye. And as soon as I hit save, let's move this over a little bit here. As soon as I hit save, you'll notice that my browser immediately refreshes and I can see those changes right here in the UI. And this goes for HTML, JavaScript. As soon as I'm hitting save, we're instantly getting a refreshed view of this component here. So pretty cool, and really the local development experience you expect from any modern developer framework. So the main thing to take away from these simpler components is that we're able to compile these on the fly. We're exposing them through an API endpoint on our local server, and we're also providing the functionality and resolution capability for resolving Lightning components. So you can notice here in VS Code, we've got some useful hovers for Lightning components. So if you need more documentation as you're doing development, we have that all online. You can see all of the attributes and things. You can also go take a look at the APIs and component library. But all of that information needed to resolve those components is available on the local development server. We're also resolving other components on your workspace. So you see this view source button, we're able to resolve that locally as well. So this is resolving all the nested components within your component as well. So pretty cool. Let's see. So I think I also talked about that you're getting SLDS styling out of the box. So you're getting it's basically looking exactly the same as it looks in your org today. So we've already gone through editing and auto refresh. We are also handling eventing. So if you want to look at a component that does something a little bit more complicated than just a hello world, we can use this open Lightning component command locally in VS Code and open up, let's see, event, simple here. So this actually has a tracked property with an event handler from another component, the paginator. And so if we wanted to see that, that all works here too. Simple, event simple. So this is all getting properly updated and tracked in the UI, which makes it really easy to debug and whatnot. So what you're probably thinking is these are great examples, but not really useful to me because all my stuff is based in Salesforce. I have all these Salesforce specific things that I need. So I need static resources that are provided by the Salesforce server. I need data that I'm retrieving from my ListView that I wrote. I need, all of these different things that the Salesforce environment provides, but wouldn't necessarily be available on a local machine. So we actually have a solution for that for local development as well, which I will show you now. So Nate mentioned it a little bit going through the slides, but we actually allow you to, because of the nature of the fact that we are part of the SFDX command line, we're able to reuse the functionality of scratch orgs. So hopefully you're familiar with scratch orgs, but like I talked about earlier, I had already created one, and you'll notice that when I started my local development server, I didn't have to enter any additional commands here. All I did, it automatically detected that I had a default scratch org, and it created a proxy to that scratch org right out of the box with no additional functionality needed. So now, whenever I look to hit components that need data from my org, it's going to use this endpoint from the server and proxy those requests over. So let's take a look at, let's see, the create record component. So if I want to open up this component in VS Code first, I'll show you guys kind of what this looks like so you can see what we're doing behind the scenes. Just importing LWC, obviously, but we're utilizing a toast event here. We also call UI record API, which is going to create the record. And we also have to resolve, account and account name from Salesforce schema. And you'll notice this create account function is just mapped to a button. So as soon as I create the account, once that's created properly, we'll get a toast event at the end. So let's take a look at what that looks like in local development. if I jump over here, so this all resolves properly, which is nice. I can actually come in here and say, let's make a new account, Nicholas Kruk, which is me. When I hit create, you'll notice that in my dev console here that it performed a fetch and I got back a 201, and you can see the ID of the record here. This is all, again, this is all localhost here. So if I want to go back, I accidentally refreshed that, but yeah, if I want to go back and show you that account in my actual org here, you can see that that account has appeared now in my Scratch org. So I've proxy, every request I make from this UI, it's going to proxy to my org so I can resolve my components and debug them locally without needing to actually even push to the org. My new account, same thing. Again, this record I was trying to show down here was essentially this preview field. So it's posting this data directly to the fetch. Sorry, it's posting through fetch, and then it's actually getting proxied. If you look at the command line here, you can see that this is getting proxied to the actual UI API from our server side. So pretty cool functionality that we have. You also probably have components like that need to actually retrieve data, not just put data to the server. So if we wanted to look at something like, let's open, not create, let's do wire ListView. So this is a ListView, a custom ListView that we have that's utilizing the UI list API, as well as contacts. So this is going to show me, if you look at the wire here, it's going to use a wire and request the contact object and look for a specific ListView, all recipe contacts. And then all it's doing is really just has a custom template here that is going to show the list of data or the fields that are available in the org. So we can come back to our local development server here. Let me clear out the network requests so you can see what's happening. I want to go to wire list view. You'll notice that it initially loads and then it actually is performing the actual UI API requests down here. So you can see that it's requesting the records. We get back 6 records. And if I were to go to my Scratch org, you can see that this is the actual list of contacts that I have here as well. And if I similarly, just if I create data on my org, that's also going to show up in local development server on the fly, because this is getting proxied live. So I just made a new contact. So now as soon as if I refresh this UI, you can see that my contact now showed up in my local environment as well. So all pretty cool stuff. And the fact that we're able to resolve wires and UI API, and Nate talked about Apex a little bit, but that is also something that we're planning on supporting and we're going to support. It's not something that's currently working yet, but it's really a few weeks from being ready. So, and it's something that we plan on shipping along with the initial version of our beta functionality, because I know that, Apex is something that's very widely used. Let's see, so what else do we want to talk about here? So the one thing I was going to call out that I think I glossed over a little bit is that this is effectively the same functionality that's happening within, your org. So if we go back to the create record scenario, when I was creating the records, this is the exact same flow that the component in my org would do. So if I went here and looked at the network requests within create LDS record, and I said my new record, you'll see that this is essentially hitting the exact same API that we hit whenever we're calling this the same API locally. So you can see that this has the same set of data just being called through Aura and then getting back the same response, and then we're going to be able to see those in the UI here. So pretty cool that all that works through local development. What does that really mean practically for your day-to-day development? Well, it really helps in terms of the whenever you're iterating on like a container and a set of components within your application. And Nate mentioned we're going to be supporting Flexi Pages. Those aren't ready yet, but you can, in the meantime, create a container component that has the components you want to test against and use those locally. For these purposes, let's jump in and create a new component for this demo. I can use the create lightning web component command, nicely available in VS Code. Let's call it webinar example. Put it in the default directory. And you'll notice that in the background, we're listening to changes on the file system. So even as I just created this webinar example, it's already in my list. So you can see that it showed up in my component list here. So when I click this, obviously nothing's going to show up because we don't actually have anything in our example yet. So if I were doing normal development and I wanted to add in some additional stuff into my container here, we could add in some SLDS styling, which, by the way, if you were at TDX, there was a pretty cool demo on the new language server functionality coming from us for SLDS. So you get similar content assist within SLDS styles as you do within our normal component structure. So in here, let's grab some components that I have locally. So if I command space, I think I want to use static resources. So I'll grab this. You notice that I'm getting content assist on all my components locally through the language server, which is really helpful. And so everything I'm typing, it's pretty easy to remember and go through. And as I hit save and I'm doing this development here, it's going to be updating in the UI. So I can just throw my components in here. Let's add in some like other cool libraries like D3. Hit save here. It's cool. So every time I'm making changes, I can see immediately in the UI, these things get updated. So let's add in like the Moment.js library too, because that one's cool for you guys to see. Oh no, I must have forgot something. So this is kind of, like Nate mentioned, one of the better features of local development because it gives you out of the box errors and good error reporting as things are happening in real time. So I just added this component in and I hit save and immediately things went from fine and great looking to, oh no, this is not working at all. But luckily we have this great, UI here to show you exactly what's going on. So looks like we have a problem with the decorator. It shows the exact line number right here that it has the problem, as well as like when available, actually showing the specific source file line. So this isn't even open in my VS Code, but it shows me, oh look, I actually just had a misspelling here, so this can't even compile because track isn't an actual error. So in order to fix this, if I needed the stack trace, I have it here, but I don't because I can just click go to source. This immediately opens up right to the line in VS Code for where the error is. So I can see if I was actually smarter, I would have listened to my linting errors because you can see that we actually provide this as part of the VS Code tooling as well, that you have error messages right in line telling you what's going on. So let's correct that error and get back on track, and then everything should be working. Again, notice now instead of a compile time error, we have a runtime error. So we're still going to resolve everything for the local development server. So our other components are running in the background, but Moment.js still isn't working because we had another problem. Looks like the Lightning input field is missing the label attribute. Well, that makes sense because that's required. We just forgot to add one here. So I can just jump over to Moment.js and look at my inputs and go, okay, well, we're missing a label here. Let's just add one in. Again, getting content assist, so let's add in a simple one. And then as I hit save, my UI is rendered now. And I would be kind of back on track with my development cycle and able to now push this page to my org and be happy with it rather than being frustrated by constantly having to, repush and revalidate, through the SFDX command line as I was like iterating over these errors that I kept hitting. So really, really useful. I think one of the best parts about having local development. One other thing that I kind of wanted to preview really quickly, I've got a couple minutes left before we want to do Q&A, but we've added some new features into VS Code as well that will help you with your development cycle. So if you want to jump into, these are available today, this part is at least. If you want to jump in and actually open up your Lightning Explorer, this is a new view that we now provide as a preview feature. You can jump into the settings and click this checkbox here for preview feature, show the Lightning Explorer. And you'll notice that you have this little lightning icon that shows up here in the sidebar now. So you're actually able to get at all of your components directly listed in the UI here. So you're able to see, all of your custom components along with, their various API endpoints, as well as like jump to them really quickly. So it's something I recommend you guys use while you're using local development, hopefully in the next month or two, because it really helps in terms of getting a feel for what components are available, as well as any components that are provided by Salesforce. You can quickly jump over to the component library and take a look at examples and things for them. And then finally, like as far as the other things that we provide as part of component library, we have really nice examples up here. So this kind of is a local development environment prior to the local development existing. It's called the playground. So if you guys want to play around with LWC and you haven't yet, I recommend coming here and trying it out. Note, this isn't the same exact feature set we have locally, because this is just kind of generic LWC working on the web, but you're able to kind of go through and mess around and see, make live edits and see changes the same way you would locally. And you're able to see kind of the things render side by side there. Obviously, it doesn't work because with an SFDX project, because this is, in the cloud here on Heroku, but it's just something to kind of tide you over until we actually have local development ready for you to use. Let's see, what else did I want to talk about here? Jumping back to the slides to recap a little bit, we kind of went through all the various scenarios that you could edit, view, how we were resolving modules locally, how we're doing live reload, and essentially utilizing the scratch org to proxy data to, which obviously is not a requirement, but it is actually really nice that if you do have a scratch org, I recommend using that so you can get additional functionality locally. We're also providing beautiful error messages that really give you the exact feedback you need to correct your components on the fly. And then, coming in the future, we obviously have Flexi Pages and mock data and live data recording. So essentially those requests you saw me hitting the server with, we'll be able to kind of take those and save them on the file system for you for your testing and playback, especially if you want a fully offline scenario. And then lastly, the production-like environment. So there are things like you might have noticed while I was working locally and creating, my new accounts through the proxy to the org, I wasn't getting a toast notification at the end. And that's because we don't have the actual production-like environment available yet locally in terms of having a container that will handle the various APIs and events that One.app handles. But that is something that we're gonna iterate towards, as part of this. But I think for the preview and beta, we just want to get out the base support so you guys can start utilizing this in your day-to-day development and provide us with feedback, because really, your feedback is most important. So please, go on Trailhead, take some of the Lightning Web Component trails and ask a lot of questions now, because we have about 15 minutes to go through kind of the list of questions that people have been providing. And then I think I can toss it back over to the moderator here, and we'll go through some of the Q&A. And
Yep. All right.
Thanks to everybody for tuning in.
Yep. Thank you. All right. This first question is for Nate. Where can I get Salesforce CLI?
It's on our website. I think, honestly, the easiest thing is probably just to search for Salesforce CLI on Google. It's at, if you go to developer.salesforce.com, though, you'll find links to it there.
Great, thanks. And another question for you. Does offline Lightning Web Components development work in IntelliJ plus Illuminated Cloud and the Welkin Suite IDE, or do I have to use VS Code? Will these IDEs have extensions for local development?
Yeah, so I talked about this a little bit earlier, but just to reiterate, so the core of this is a CLI plugin that will be exposed then through VS Code. I'm actively working with Illuminated Cloud to have them integrate with it. As far as Welkin Suite, they haven't reached out. I haven't chatted with them about it, but it'll be available for any IDE to integrate with. Yeah.
Yeah, and to be clear, the only piece you really need is the SFDX CLI, because that's providing the actual local development server component. And then there may be like little integrations we do with these various IDEs, but you don't need a specific IDE to use local development.
Can I interact with Apex in my org with LWC Dev?
Yes, you will be able to. As far as preview goes, we will have this functionality available. The same way I was showing UI API working, we'll have Apex working as well. We have, I'd say, like it's 60% working now. We're just kind of tidying things up to the point so I couldn't actually demo today, but it will be available when we preview in a month or two. So.
Cool. Another couple questions for Nick. Will local development respect global SLDS styling given the shadow DOM disallows global styles?
Yeah, that's a good question. So we're trying to replicate a production environment as much as we can. So we want your components to look the same locally as they will in production. I'm not going to guarantee that that will be the case for the first beta preview, but yes, I mean, it should be the case that anything, like if you're using Shadow DOM, you should be able, like the same thing should be prevented in local development that would be prevented in production. So I hope that answers the question.
Will the local server cache responses from the remote server calls so you could work disconnected from the org?
Yes. So that's, I don't know if I explained that well enough earlier, but essentially, you know, that is part of the mock data and like local data support that we're going to provide. Essentially, we're providing the capability to record those requests so you could work fully disconnected in an offline capacity. We also want to provide the ability for you to like automatically mock things out. Like if you wanted to just drop some JSON into a folder and have that be your data representation, and we could return that as the response from some Apex controller or something locally, you know, we could mock it out that way as well for you. So yes, that will work.
Great, and we got this question quite a bit, and it's pretty lengthy, but so did I hear this right that this will be beta soon, or is this live preview ready now to use when it is available? Do I just need VS Code, CLI, SFDX, VSC extensions installed? Did I hear node application? Is there anything else required? Thank you.
Yeah,
yes.
so I can take this one. So yes, it will be ready soon. We're targeting August timeframe. I can't guarantee anything, but that's about how it's looking from an IC perspective on our side. It's not ready to use now. I was kind of calling out that you could look at the playground and component library now in the meantime for the next month or two to get familiarized with LWC more. And as far as what you need, it's really the SFDX CLI. I mean, that's the main thing that you're going to need, and that provides all the other things that you're going to need to run local development. And then obviously VS Code is a bonus, and you should use it because we have a lot of good tools in there. But yeah, those are the only two.
Great.
Yeah, and probably to add, I mean, node is required. Yeah, right, Nick.
Yeah, I mean, it's required, but I don't think you have to do anything for that. I think it's package it, but yeah, I mean.
Yeah, we're working on a bunch of things to make the setup process easier for VS Code. You know, looking at potentially like a single installer that kind of gets everything set up for you. But yeah, I mean, LWC development really, to really do anything meaningful, you are going to need Node because you'll need it, you'll need it to like run just tests and things like that.
Yep.
Why do we need mock data? We embed IDS in mock data.
So the whole thing with, I mean, it's optional. You don't necessarily need it. Like the idea with mock data, though, the really big thing is it's about repeatability. So if you're doing something in development and you want to repeat, like click a button and have it result in the same thing every time, like mock data allows you to do that. And then because, building on top of repeatability, it allows you to build automated tests. So by having all of your backend, what essentially is your backend services mocked, you can write tests that actually test all of your UI interactions, so that you can more easily find if something's broken in your UI rather than like something being caused by a server side issue.
Yep, and to clarify too, I mean, you definitely don't need the mock data, but it's going to be super helpful in terms of like the testing scenarios if you're not trying to test against a physical org. This lets you kind of disconnect from the org completely and just supply the data from like your Git repository rather than having to go over the wire. So I think that's the main motivation there. But obviously you can always go directly to an org to get that data too.
Will there be any support to emulate communities locally?
Yes, that's the answer.
Great. Is the tool discussed in this webinar different to the LWC Create App tool on LWC.dev?
Yeah, yeah. So this is something that has caused some confusion, and we need to get better at clarifying. So there are two kinds of there's two types of LWC development. There's LWC development for Salesforce, and there's LWC development outside of Salesforce. So similar to other web frameworks, like you could actually build an LWC app and like deploy it to Heroku or any other place. So the Create LWC app is more analogous to, if you're familiar with like Create React app, or there's a few other ones out there. It's for building non-Salesforce platform apps. So if you want to write, if you just want to have this be completely standalone, but with that you're not going to get like all of the you're not going to get all of like the Salesforce specific stuff like Locker and all and all these APIs. It's just the raw LWC framework. So if you're talking about Salesforce development, the whole LWC.dev site is really not for that. You should stick to the stuff on developer.salesforce.com.
Yep.
How do we ensure local dev is par with the latest Salesforce release version, like API version 46 or 47?
Yeah, that's an easy one. So we're planning on, if you're in an SFDX project and you're authenticating against a specific org, like you're a Scratch org, we're going to utilize the API version from that org to ensure that it's equivalent to what you're using in production. So that we'll resolve that under the covers for you through the SFDX CLI.
As far as this is something it's probably still, there's some TBD here, and it'd be good to get feedback on, but generally speaking, with developer tools, we really only support the current version, the current version. So if you're talking about things like APIs changing and stuff, I would imagine that at best we're going to officially support like the current release and then like the next preview release. It's unlikely that we will provide support for local development that will go back indefinitely. So if you wanted to stay forever on like version 46, you will likely end up starting to have problems with local development. Like for this, and this is really the same as how VS Code is and the CLI. Like we really optimize for the current version of the API.
Got it. And then another question for Nick. Will native components like Lightning Icon work locally as well?
Yes, they will.
Great. Is the port number for LWC local configurable?
It is configurable. I didn't dive into that too much, but essentially we're allowing you to supply that over the command line arguments, and then we'll also have like a set JSON file that you can use to configure it if you want to have a specific project be configured a certain way each time. That way you can have your local development server on different ports for all of your different projects running locally, so they don't interfere, things like that. So yeah.
Is this only for LWC? Could it be used for Visualforce?
This is only for LWC currently. Yes, and I can't imagine it being used for Visualforce, but
yeah, it's unlikely we're gonna support Visualforce or in local development.
Yeah, to do that, we would need to ship you the compiler, right, locally, and for Visualforce, that's just problematic.
I see that you're using a Scratch org for your demo, but is DX required to develop locally with LWC?
Yeah, so it's not. And I think we just kind of targeted this scenario for our initial release, but we plan on supporting the OSS scenario too, where you're just using LWC outside of the context of SFDX, but we're still supplying all the tooling through the SFDX command line currently. So, but yeah.
And I'd like to add just a little bit of a clarification to this one. So DX, this is my usual caveat that we're trying to communicate, but so DX is not, there isn't a product called DX. Like the idea of DX is, it literally means developer experience. It's a suite of things. So like Scratch orgs are part of DX, packaging is part of DX, the Visual Studio Code extension. So yeah, so I mean, as Nick said, you don't have to use Scratch orgs, but like, I just want to be very clear that like you can use, VS Code with sandboxes. You can use LWC with sandboxes. Like Scratch orgs are just one feature that exists in this ecosystem that you can use or not use depending on your development model.
Great, and I think we have time for one final question. Does SLDS styling include the theme treatment for the org it's placed in, or is there a different way of calling in style sheets from the org that LWC is attached to?
Yeah, so at least for the beta preview version, there isn't a way to do that. But like Nate had talked about earlier, as far as future-looking things we're planning to do with the containers, that's something we'll be looking to support. But right now, it's just set standard SLDS with no additional theming or anything from your org.
That concludes our webinar on local development. Thank you for joining us today. We hope that you attend more of our webinars in the future. Enjoy the rest of your day. Thank you.